Today we're going to be looking at the torque application on a bracket or through an attachment to better understand where the torque is expressed and dispel many beliefs that there is a point of application when there is torque application. So if we assume that we are going to apply a torquing motion using a rectangular wire on this bracket slot, which is slightly angulated, we'll need to activate the wire this way. And once the wire is inserted into the bracket, it will deactivate in the opposite direction, giving you a torque effect that will tend to push the apex lingually, which is what you want. And many people believe that the center rotation of the tooth will be either at the incisal edge, call it number 1, or at the bracket slot, call it number 2. In reality, this torque application is independent of the point of application, and for mathematical reason will be expressed at the center of resistance, which is number 3. So we're going to have a look now on why is a force has a point of application. If you push a force this way, or you push the force here, you will have vastly different effects on the tooth movement. But when you have a force couple on an object, which consists of two equal and opposite forces, so that's F1, that's F2, and remember that F2 equals minus F1, and you have a distance. So this is a force couple, and there is no point of application, and let's see how we can prove it. So let me draw my small diagram. So now we have, as we did before, we had F1, F2, and let's call this distance R2. Then we'll say, okay, what happens if I put a point of application theoretical here? Let's call this point M. So you can calculate now that you can see that you have two moments, and this one will be R1. I do apologize, I forgot this distance. So you can decompose this geometric figure into M equals, first moment is here, F1 times R1, but then there is a second moment on the other side, plus F2 times R2 plus R1. So that's the distance, R1 plus R2 for F2. This is moment. This moment is counterclockwise, and this moment is clockwise. Okay? We can further calculate M. equals F1 R1 plus F2 R2 plus F2 R1. But we already know that F2 equals minus F1. So now we have M equals F1 R1 plus F2 R2 minus F1 R1. I just replaced the F1, the F2 by the F1. So this one and this one can be eliminated, and you can see that M equals F2 R2. That makes sense, which is exactly what we said. This is the definition of this couple. F2 times the distance, F times R, gives you the force coupled amplitude. So say, okay, maybe let's move now the point of applications to M prime and see if now the point of application of the force makes a difference. So now we have M prime equals, this is the first moment, and let's call this distance R. R plus R1 times F1, so that's F1 times R1 plus R, right? You agree? And we need to add the second moment created by F2 times, but this time we need to add R2, R1, and R for the distance, so that's R2, plus R1 plus R. So those two moments are applied to the point M prime. So M prime equals F1 R1 plus F1 R for this equation, for this parenthesis, plus F2 R2 plus F2 R1 plus F2 R. So then we can have a look at it again. So M prime equals F1 R1 plus F1 R plus F2 R2 minus F1 R1 minus F1 R. Again, plus this one, plus this one. This one, F1 can be removed from the equation. So M prime now equals F2 R2, and we can deduct that M equals M prime, which means that the point of application of the force couple is independent for a free object, again, of the point of application of the moment of the forces. So this is very important to understand, because again, now when we put this moment to the bracket, it will be calculated on every point of this tooth as the same. Every point will feel the same couple, and the point of interest for us is CR. So this is a particular point on the tooth, as you know. So we're going to keep this and do the mathematical calculations at CR. Keep in mind, However, that there may be some variability due to the fact that the dental-alveolar processes and the PDL are not necessarily constant, and the force couple may be changing due to difference in remodeling. So thank you for your attention.